I'll just switch off this. Good afternoon, everyone. And I am particularly grateful to the SN Board Center and to the director, Sreerup, whom I know from student days, just like I know the chair of this session, for inviting me to give this talk. And it is a privilege to be talking in a center like this. Also a privilege to be standing in front of a portrait of the person whose voice we just heard and giving this talk. Now, before I start, I would like to say something. That this is a talk which is about the history of science. I'm going to talk about developments, how modern science came to India, how it developed, and what are the things which are going on now, not in the kind of detail which you heard in the morning, but sort of a broader overview, a bigger canvas. Now, of course, whenever you look at history, there are opinions, there are isms. And I, personally, am a believer in what Raychaudhuri used to say, that historians should have no isms. Should present history as things happen. After that, the interpretation is left to you. You add your own ism to that. So I will try to follow that and keep the thing as neutral as possible. Just tell you about what are the facts. But anyway, let me start by.
I think let's point towards the.
Point towards?
Computer.
Okay. Okay. So this picture is actually very representative of Indian science. This is a picture of the moon surface taken by Chandrayaan-2, and this particular crater is called Mitra. It is named after S.K. Mitra. So that is why I put this picture in the background. All right, so let's begin the story. I just do the I think it's important. Okay. So modern science in so India had a glorious tradition of science in ancient times, but by the medieval times it had more or less died down. That is not to say that there were not people who knew about science, but there was no original thinking. People were only rehashing what had been done perhaps 800 to 1,000 years before. So new ideas came to India through the European advent. And as you know, technically we say the formal advent starts from Vasco da Gama's arrival at Colipur. This is not a Portuguese ship, it's a British ship, but it was on such ships that people came and brought their new ideas. Okay, now come to this part of the country. And as you all know, the story starts with Nawab Siraj-ud-Dawla, who took over. He was arrogant and tactless. The result was that there were three of his major people in his court. There was the General Mir Jafar, there was his financier Jagat Seth, and there was his biggest feudatory Maharaja Krishna Chandra of Krishna Nadia. And there was Robert Clive, who stood for the British, and he immediately got it. So all these people, he had upset all of them. And the British he was upset with the British because for many years they had not paid their taxes. So the conflict, what happened was that all these people got together and basically they ran rings around Siraj, who had no clue what was going on behind his back. So, as you know, the result of all this conspiracy and counter-conspiracy, about which Siraj had no idea, was it ended with the Battle of Palashi and the defeat and killing of Siraj. Now that's not the part of my story in the sense, but it gives me the background, which is that once this happened, okay, so one should not malign Siraj in his own term. Okay, just.
So why not you change the screen? Sreerup, if you just say next, they will just do that.
You can do that.
Hey, apna
Yeah, you can finish his slide. See, there's a picture of it.
So point at the
Point at
the
Please.
Okay, so next.
Next.
Go to-
One pointer.
So you see here, now, why did I tell this part of the story? Because Mir Jafar then became the new Nawab of Bengal, and the British, Clive and others, kept making demands of money on him till his treasury was empty. So at that point, he had nothing left to give. So he ceded this area, this darkened area here, and which are the 24 Parganas. So Pargana was like a subdivision. There were 24 of them, and the British called it the 24 Parganas. They are still called 24 Parganas, except that now there is a north and a south. But so this was ceded to the British that this land is yours, you tax it as you wish, take all the money from there and stop pestering me. So that's it. Next. Okay. So we come to let me but next both so you see, we start with cartography in British India. Now, when Robert Vansittart was the successor of Clive as governor of that territory in Bengal. Now, Vansittart discovered that the Nawab or the previous Mughal administration of Bengal had been very lax. I mean, taxes were not recorded properly. Sometimes they were collected, sometimes they were not collected. He wanted to make it very systematic, as it was in England. And England, from the period of the Norman conquest, which was 1066 AD, from that time they had a book, which is called the Doomsday Book. It's a copy of the Doomsday Book, which is the British. Every land holding, every tree, every pond, everything which could be taxed was written down in that book. So Vansittart wanted a Doomsday Book for the 24 Parganas. And to make that book, he employed a young guy called James Rennell. So James Rennell, okay, in those days everyone wore these white wigs. This actually general at a very young age. He was employed at the age of 22. Okay. Now Rennell had learned map making. He was a seaman. We know how to make maps. So it is James Rennell who first created the first maps of Bengal. And after 24 Parganas, and the British were looking ahead to when they would conquer all of Bengal. So they asked to make maps of all of Bengal. He did that. So this kind of map which you're seeing, this is James Rennell's map, 1779. And you see that this is a modern map, drawn to scale and with the kind of details we are used to see. No such maps had ever been drawn in India before. There are hand-drawn maps. Some of them are in the Bharat KalaBhavan museum, which I know, which have lots of fancy things, a few animals and so on also drawn here and there, but not this kind of a scientific map. So in that sense, James Rennell was the first modern scientist to work in India. Of course, he was not Indian. Now, in 1765, the British were able to get the Diwani, which means tax collecting, of Bengal from the Emperor Shah. Of course, this picture was later drawn by a British artist. It didn't happen like that. Shah was a prisoner and it was sort of forced out of him. But this one looks as if he's sitting on his throne and giving it to people. Of course, you can see Indian people here are not happy. So this was a painting later. But now the British could happily. So you see that the map making extended not just over Bengal. Okay, all of this was Bengal in those days, but he went all the way up and then so made lots of maps. This part was dense and is still mostly dense jungle, so you could go there. Now, what happened to Rennell? Then in 1766, this was in the wake of the Sannyasi rebellion. That's the one which is described in Ananda Mott, and you heard Vande Mataram in the morning, so which is there in that book. So of course, sannyasis were defeated by the British troops of the East India Company, So he fell in with the party of these sannyasis, and all that they saw, they didn't know anything about map making. They saw a white person, he exiled hai unko pita. So they beat him up. So and he was almost killed. Many of his bones were broken. Then he came and recovered for a year in hospital. And once he left India, he had decided he lived for another 53 years. He said he will never come back to India again. And it is not surprising. So this ended the career of the Indian career of the first scientist of India. Now, the first college to be set up by the British is the Mohammedan College of Calcutta. Now, this was set up by Warren Hastings, and it taught Persian, Arabic, law, and natural philosophy. And this is widely known as the Calcutta Madrasa. It was renamed by the University to Fazli. I'll tell you the story of this in a moment, but let me just show you my slides. So here is the Calcutta Madrasa, which you may be familiar with. It's in the Delhi area. And now it has a new campus in Newtown. I must say I prefer the older building. Okay. But now, what was the story? The entire administration of Bengal was done in Persian and Arabic, because those were the languages used by the Mughals and by the Nawabs. Now, the British employees of the East India Company, they knew none of this. So they had to rely on interpreters, Doghashis, who would do it. Now, the Doghashis realized that here is a wonderful opportunity to make money. So if the British officer told somebody, you have to pay 50 rupees, the Dobashi said, আপনাকে 100 টাকা দিতে বলছি। So after some time, the British are not fools, they realized this. So then Warren Hastings set up this college. The purpose was to teach his people Arabic and Persian so that they could not be fooled like he said. Okay.
The culture was there,
Nothing changes. Okay. Now I move south. And this is a painting of the siege of Sreerup. And this is where Tipu Sultan was, defeated and killed, and by Arthur Wellesley, who later became famous as the Duke of Wellington for having defeated Napoleon. Now, during this campaign, by the way, the campaigns against Mysore were some of the toughest campaigns which the British fought, according to their own records. And the major reason is that the land in that area is sort of hilly. There are little hills, there are little plains, ravines, there are riverbeds. It wasn't properly surveyed. So the British didn't know where they were going. And sometimes they got lost. Sometimes they were easily ambushed by the troops. They knew the place very well. They had grown up there. It was their own country. So there was a deed felt by Arthur Wellesley. He felt that there should be good maps of that area if they're going to control it. And he found the right person in somebody called William Lambton, who was a colonel, but who knew surveying, who had learned some surveying. And Lambton, the story about Lambton is that apparently he was with some regiment, and they were marching, according to themselves, they were marching towards the British camp. It is Lambton who looked at the stars and said, look, we are marching straight at Srinagar. So if we come out in the open in the morning, then we will be in front of Tipu's entire army. So let's turn around and go back. So there was some confidence that Lambton knew what he was talking about. So that's why we come to William Lambton. So Lambton initiated what was called the Great Trigonometric Survey. I'll talk about that in a moment. So it was initiated by Lambton in 1806. Then Lambton died in 1823. And after 1823, it was continued by Sir George Ebrist. So Lambton and Ebrist. Now remember that for this trigonometric survey, they created this kind of triangles. I'll talk about triangulation in a moment, but everyone here knows about it. So I'll skip that. I'll go very fast. The role of Indians at this point was still minimal. This was the role, to fetch and carry, to carry the things, to cook the meals, only menial jobs. The entire survey was done by Europeans. Still, it was science which was being done in India. It was a measurement of India. Now, triangulation, of course, you know what that is. If you are going to if you have points there which you cannot access, but you are here, and let us say there's a forest in between here, there's a water body, you can't go there. Directly, you can't put a chain and measure it. But what you can do is erect a triangle. You can go here, and of course, The three things you can measure are this length and these two angles, and then you simply use the sum of angles and use the side, and you can calculate the other two sides. Fine, now you go around and go to that point, and if there is another point, let us say, which you cannot access, again, maybe there's a forest there, so you create another triangle, and this way you can build up this grid of triangles. And that's actually what they did. See, these are the actual triangles built up, and they started from Madras, from the peak of Mylapore, where now the Santham Cathedral stands, and they started and it spread out. So you see, they had only built the backbone because that would give them the scale, and then they could put in the details by hand. All right, now I come to the British India in the 1820s. This map is from later, but you see, most of India was then under the British. The yellow places are the princely states, which had been already, they had alliances, the vassal states. All of India was controlled. Now, to do this, the British had to defeat first the Mughals, the Marathas, the Sikhs, the Awadhis, Nawab and the Burmese. And all these wars cost money. Okay, wars are expensive. If you've been following the news, you know that. So the East India Company, by about 1820, was making a loss of £1 million per year. I remember the pound was worth much more then. So they needed to do some economies. So they brought in a guy who was famous for his economies. And his name was Lord William Bentinck. Okay. Now, why Bentinck? Bentinck was good at, making economies and improving finances. There's another reason. The point is that if you are people who have held administrative positions will know that if you make reforms by which people's privileges, which they have been enjoying, are curtailed, there will always be people who will move against you. And then if there is political pressure can be brought, then you will be dismissed and replaced by somebody more prior. I mean, the history is full of such stories. Now, the reason why they could do this for William Bentinck is because his father, the Duke of Portland, was the Prime Minister. So, being the Prime Minister's son, he could do what he liked. So, that's the reason. Now, among other things about finances, in fact, Bentinck used economies and many things to improve the finances so that when he left India, the company was making a profit of £1 million per year. It was at the expense of our ancestors, but that's a different story. From the East India Company of view, it was a great success. Now, of course, we remember Bentinck today for the social reforms, for banning Sati-Daw, for banning the infanticide of female children, and of course for suppressing the thugs. So, however, the other important thing which is relevant to this story is the Law and Education Minister on his council, the Viceroy's Council or the Governor General's Council, was Lord Macaulay. And it is Lord Macaulay who, in 1835, wrote this famous minute, just known as Macaulay's Minute. And in this minute, he very strongly advocated that the British government should not build Mohammedan colleges, and of course there was the Sanskrit College of Banaras, all built by the British. But no, should support only English education. I'll come to that. But let's look at his actual words. We must at present do our best to form a class who may be interpreters between us and the millions whom we govern, a class of persons Indian in blood and color, but English in tastes and opinions and morals and intellect. To that class, we may leave it to refine the vernacular dialects of the country, to enrich those dialects with terms of science borrowed from the Western nomenclature, and to render them by degrees fit vehicles for conveying knowledge to the great mass of the population. This program has been partially successful. We are all examples of that. We are all done Western science, Western education. I give you this lecture in English. We are using Western technology to do this. So in that sense, this has been a great success. Of course, it has not reached the great mass of the population. Now, a little more about Macaulay, because he's a very interesting and complex character. So during the nationalist struggle, and nowadays we hear this again, Macaulay has been vilified as a cunning villain who planned to train Indians in Western wars so that they would remain slaves to the English forever. And we keep hearing, and that narrative was there earlier, we keep hearing it. Now, of course, there's no question that Macaulay had negative things. He was insular, he was biggish, he was patronizing, he was racist, he was misogynistic, as you can see from his writings. But this just shows that he was a man of his time. At that time, all important men were like this. But here I will show you, I will give you a quote from a talk by Macaulay. So Macaulay, like most of the English people of his time, believed that English is the best language in the world. Of course, I believe that Bengali is the best language in the world. Those who speak Hindi believe that Hindi is the best language. It's sort of natural. But of course, English is a rich language. It's rich in science, which was not there in India. And so he genuinely believed that it's important to teach Indians Western science and also Western language. So he says, his rhetorical question, are we to keep the people of India ignorant in order that we can keep them submissive? Or do we think that we can give them knowledge without awakening ambition, that is ambition for self-rule? Or do we need and so on? Who will answer any of these questions affirmatively? Who's going to say yes to this? Answer to all this is no. Yet then he says, himself he said, I have no fears. The path of duty is plain before us. We must give modern education to the Indians. So you see, he's an idealist. His ideas may be different from what we think they should have been. But then he goes on and says, it may be that the public mind of India may expand on our system till it has outgrown that system. That having become instructed European knowledge, they may in some future age demand European institutions. In other words, they may want to govern themselves. Whether such a day will ever come, I know not, but never will I attempt to avert or to retirement. Okay. So he says, okay. Now, of course, he was probably thinking that Indians will demand independence in another 100, 200, 300 years. It happened in 50 years. So this minute is 1835, and the Indian National Congress was founded in 1885, exactly 50 years. It is interesting that the early leaders were all trained in English, and they were all went to England to train as lawyers. So it is the same training which Macaulay had recommended, which rebounded, and finally, and another 50 years, we got our independence. So it worked. What Macaulay had thought worked, maybe at a faster time scale than he had thought. So, as I said, mixed. Okay, come back to William Bentinck and Macaulay, because what Bentinck realized is that if you want to raise more money from India, there's no more pressure you can put on the local rajas and local chieftains and so on. If you put more pressure, there will be more wars. If there are more wars, you will spend more money. So better not to put pressure on the people, but to raise the natural resources of the country. Now, to raise the natural resources, you have to know where they are, you have to know what they are. First thing you need to know is to know where they are. So the first thing he set up was the Great Trigonometric Survey of which Everest had been leading. He converted that into the Survey of India. So that is to tell you exact locations. Then came then came the ancestors. They were committees to begin with. The Geological Survey of India to tell you where the mineral wealth lay. Where is the gold? Where is the iron? Where is the other precious minerals to take out? Third thing was the Botanical Survey of India. Where is the botanical wealth? And the fourth is the Zoological Survey of India. These are, by the way, the logos of all these institutions today. So all of them, so these three started as committees, which then grew into these surveys, but they were all started by Bentinck, and this was the purpose. It was not a philanthropic purpose. It was to raise as much money as possible, but it had good effects. All right, now I come to the question, story of Indian computers. So computer in those days didn't mean a machine where you sat and typed, but it meant a poor fellow who sat and did arithmetic, addition, multiplication, and so on by hand. They were called computers. They were reasonably well paid for their hard work, but it was, as you can guess, extremely tedious work. However, the money was certainly better than you could get in as a clerk in a commercial company. Now, he asked for 30 computers for the Survey of India, and Lord Bentinck is the person who invented outsourcing. He says, don't employ Europeans, take Indians. Arthik Mainedia, Indian. So, as I said, the roots of outsourcing go very deep. Now, where to get those Indians? There's only one place they were available. So Everest went to John Tytler, you see his photo here, the professor of mathematics of the Hindu Mahapathshala in Kolkata. Now, Professor Tytler recommended 9 young men All were employed by the Survey of India as computers. Okay, within 1 year, 8 of them left. Only one guy survived. Yes. But these 9, they were the first Indians to be doing modern science in India. Previously, modern science had been done, but all by Europeans. But these were Indians doing the modern science. Okay, now the only guy who survived, I'll come to him in a moment. So, of course, before this, the Hindu Mahapathshala, you're familiar with this. So now Presidency University, and the moving of because it was Rammohn Roy and David Hare, but none of them were actually involved in the first committee. Rammohn Roy, because most of the money to start the Hindu Mahapathshala came from the rich Hindu zamindars, like the Dev family of Shubhavazar and so on. And they were all very orthodox Hindus. And they said, if Rammohn Roy has anything to do with it, we are not going to give any money. Because Rammohn Roy, they were upset with him because he had asked for good reforms like Sati and so on. So no Rammohn Roy. What about David Hare? So David Hare was a humble watchmaker. He had a Ghodi Dukan in Govardhan. And the British didn't think he was important enough to be put up. So the person who came in was a friend of Rammohn Roy, whose name was Boidranath Mukherjee. So it is Boidranath Mukherjee who set up the first council. I couldn't find a picture. So I give you a Babu Mashai by Lalu Prasad. So, but he's the person who is, everywhere he's referred to as Babu Boidranath Mukherjee. So he's the guy who actually set up the college. Now, the one person who survived was Radhanath Sikdar, and his name is famous because he is the scientist who computed in 1850 the height of this peak, which was known then as peak 15, as 29,000 plus minus 34 feet. Okay, that is the left hand. Now, did Radhanath Sikdar discover the highest mountain in the world? No. Well, many people think so, but that's not true. What he did was that he computed the height accurately. Before him, the surveying had been done by the British scientists. There were many scientists, Colonel Waugh, then Armstrong, Nicholson, who had done all the surveying. Radhanath Sikdar had not even gone to survey. He was sitting in Kolkata and with his pencil and paper and doing computation. So what was his contribution? That is the important one. See, the surveyors who were doing this survey, they were simple people. They were able to take the survey and write out the notes and then. But Radhanath Sikdar understood spherical geometry. He understood atmospheric refraction. He understood about the variation of the lengths of chains and so on, the geometric lengths. So he could make all the corrections. And what happened? Also, one more thing. See, Mount Everest is on the border between Nepal and Tibet. Now, at that time, Tibet was closed to all foreigners. No foreigners could come in. The Dalai Lama had forbidden it. The British had had 4 Anglo-Nepal wars. So Nepal was closed to any British heritage. If you can't enter Nepal and you can't enter Tibet, then how do you measure the height of Everest? The only possibility is that from North Bihar, when the weather is good, then you can see Everest. You can see Everest, and then you can. So from 6 positions, there was a British surveyor called Nicholson who took the position from 6 positions. And those data are there. So they were given to, and from there he calculated that Everest is 32,000 feet high. All right. Because he was doing a rough calculation. So when it was handed to, see what happens is that if there's atmospheric refraction, then it tends to make the peak look higher than it is. The curvature of the earth will also make the peak seem higher than it is. So result is that the corrections have to be made, and Radhanath Sikdar was the right person who knew how to do it. Once he knew them, these are his results. And often there are many myths made about this 29,002, they are all wrong. Okay, there are 6 results, and if you take the average and standard deviation, then this is what you get. Okay, so today the height of Mount Everest has become, when I was a student, it was 29,028 was the central value. And now it has become 29,035 after the Nepal earthquake. It is risen by 7 feet. Okay. Then the point which I'm trying to make is, I'll repeat it again. Radhanath Sikdar was not the discoverer of the highest mountain in the world, but he proved to both the colonial, because at that time they had a feeling that Indians are only good for philosophy. They are not good at practical science. But he proved that Indians could practice modern science as well as the Europeans. So in a sense, all of us who are scientists, we owe our inspiration to Rajanashri. He's the first to have said, to have shown that yes, see, I can do science as well as any science. All right. Now let me talk about Ramchandra, who is a forgotten mathematician. Most people have not heard of him. See, he published a very interesting book. That is Ramchandra Lal. He taught at the Delhi College. It's now called the Zakir Hussain Delhi College. And I'll come to this part later. So he wrote a book called Treatise on Problems of Maxima and Minima solved by algebra. Of course, if you want to find maxima and minima, normally we do it by calculus. But he has ingenious methods, starting from as simple as a thing that to take a straight line, partition it in the middle, such that the product of these two is maximum. How to do it? So now, of course, what you would do is take this as x, take this as x minus a or a minus x, multiply and then do ddx. That's the standard thing which we do. But he had an ingenious construction by which he could do it even without just by algebra. Then the problems become harder and harder. Till lastly, there are problems of solid geometry and this is mathematically beautiful. And this was, of course, when he published it, there were criticisms in the papers. All the reviewers wrote that what is the use of this? It's all useless. Since you have calculus, why bother to do this? So only the one person who recognized its importance was Augustus De Morgan. You have heard of De Morgan's laws. And he was then the president of the British Mathematical Society. It is De Morgan who recognized that these are mathematically brilliant. And this is De Morgan's house in London. I've taken this photo myself. This door, this says London Mathematical Society. And here, so it is because of De Morgan that he got signed. You can see the foreword is by Augustus De Morgan. So sometimes Ramchandra Lal is referred to as De Morgan's Ramanujam. Just like Hardy discovered Ramanujam, he discovered Ramchandra Lal. But unfortunately, today he is forgotten. All right. Then we come to the War of 1857. As you know, India was taken to the crown, East India Company was closed down. But for education, it was plus point because universities were founded as the three main things. And then in 1877, Queen Victoria was declared the Empress of India. So India became a crown property rather than an East India Company. Now let me talk about the Mohammedan Anglo-Oriental College. So here's an interesting story. So Syed Ahmed Khan, he was a British magistrate, between the lowest low level of judge, but he also was a scholar of Persian. So he took this Aini Akbari of Abul Fazl, which was written in Akbar's time, and he edited. So the manuscripts, a lot of errors had crept in. So he edited a very scholarly version, and he asked Mirza Ghalib to write a takreez for him. What is a takreez? In Persian books, it's like a foreword. So, but it's written in verse. So if you want the takreez in verse, you go to the best poet of the time. So you approach Mirza Ghalib. And what Mirza Ghalib wrote was very different from what he had expected. And I'll show you a translation of that. Okay. So I'll read this out. And this idea of his means Ahmed Khan's, to establish its text and edit the Ain, puts to shame his exalted capability and potential. I, that's Ghalib, who am the enemy of pretense and have a sense of my own truthfulness, if I don't give him praise for this task, it's proper that I find occasion to praise. Then he says, look at the Sahibs of England. Look at the style and practice of these. Science and skills grow at the hands of these skilled ones. Their efforts overtook the efforts of the forebears. The fire that one brought out of stone, how well these skilled ones bring out from straw, that means from ashes. What spell had they struck on water that the vapor drives the boat in water, steamships? Go to London, for in that shining garden, the city is bright in the night without candles, gaslights. Look at the businesses of the knowledgeable ones. In every discipline, 100 innovations. So the push to do science is coming from a poet. Very interesting. Anyway, stung by this takreez, when the book was published without the takreez. Okay. And Syed abandoned history and founded the Mohammedan Anglo-Oriental College, and this in 1920 became the Aligarh Muslim University, which is today a central university with a great reputation. Now, colleges proliferated over British India in the 19th and 20th centuries. So, these all came up in Kolkata, Presidency College, St. Xavier's College, Scottish Church College. In Madras, you had these three. In Bombay, these three were the earlier ones. And of course, today they're called by different names, but the colleges are still there. Now, one interesting thing is these three colleges, St. Xavier's, the two St. Xavier's and the other college were founded by the Jesuit missionaries, Catholic missionaries. These three were founded by Protestant missionaries. And these three were founded with donations from Indian, rich Indians, and we were supposed to be, in those days, secular, which means Hindu. In those days, secular meant Hindu. That is why Presidency College was originally called Hindu Mahapathshala, because Christianity would not be taught there, and the Hindus could send their children there. So something change, and some things don't change. There are more colleges across, so they're all very well-known colleges. Langat Singh College in Muzaffarpur. This is where Babu Rajendra Prasad did his education. Ferguson College, St. Stephen's College, all very well known. Calcutta Medical College, there are technical colleges, Bengal Engineering College. This is now IIT Roorkee, Thompson College of Engineering, and finally came women's colleges. So, Bethune College, 1879 was the first. The Sarah Tucker College of 1895 is in Tirunelveli in the south, and SNDT Women's University is in Bombay. Now, with the coming of these universities came a lot of education, and by 1876, we have the first institute, research institute. And this is the Indian Association of the Calculation of Sciences. This is a long story associated with that, but I don't have the time to tell you. It was founded by Mahendra Sarkar, and the young C.V. Raman used to work there in the evening. Okay, this is a very young Raman, and this is taken from his wedding photo. Okay, it's cut out of that. Okay, now of course, this is where the IC is moved. Now let me talk about the Indian Institute of Science, and there's a nice story associated with this. So, J.N. Tata, as you know, wanted to set up the iron and steel plant at what is now called Jamshedpur. And he had some samples of iron ore from the bilateral mines of Chhattisgarh, which he had purchased. And of course, as you know, some of the highest quality iron ore in the world. So he wanted it tested. There was no lab to test it in India. So he took some sacks full of those, and he went on a ship which was crossing the Pacific and would go to America, and he wanted to test in America and then again in Europe, and then of course finally in England. The other person, his fellow passenger on that ship, was Swami Vivekananda, who was going to deliver the famous, what became the Chicago Address. Now on the ship, they made stuck up friendship, and Vivekananda asked him, "What is it? Why are you going? What are your plans?" So he told him this. So Swamiji said, "Look, the Americans are going to tell you this is extremely poor quality ore. If you take it to England, they will also say this ore is not worth mining. They don't want you to build a steel plant in India. Neither the British nor the Americans want you to build a steel plant in India. If you want it tested, take it to Germany or to Sweden." Okay. Well, JRD had it in mind, but then he went to America, he went to 2-3 labs. They all told him this is nothing in this, useless. Then he took it to England. They told him this is not worth mining. Then he took it to Sweden. They told him this is better than any of the ores we have. He took it to Germany. They said that we have never seen ores with this high iron content. So when Tata came back to India, he resolved that he would make an institute in India where such testing could be done. And that is the origin of the IISc. It's also true that when he first wanted, he wrote to Swami Vivekananda, who was still alive then, that will you become the director of this institute? And Vivekananda said, "No, I am a sannyasi and this is not my job. I'm not trained in science. You get a very famous scientist to do this job. Give it to J.C. Bose." But J.C. Bose said, "I already have my institute. I can't be director of 2 institutes. You get some well-known scientists from England. Then you will get also people from there." So they employed Sir Maurice Travers. Now, Travers, you've heard of Ramsay and Travers, who discovered the noble gases. So Ramsey was the boss, Travers was the assistant. So Travers is the first director of IIT. That's how IIT was set up. But IIT was not set up while Jamshedji Tata was alive. He didn't get the permission. The permission was later given to his sons, Durabji Tata and Ratanji Tata. They are the people who built IIT. They are the people who made the steel plant. The only one of Tata's projects which came out in his lifetime was the Raychaudhuri Hotel. He didn't get permission for any of the others. It's also true that at that time Lord Curzon was the one shared. Okay. Now the latter half of the 19th century, I'll speed up a little bit, produced two outstanding Indian scientists. You all know who they are. And they were knighted by the British, Sir Jagdish Chandra Bose, Sir Prafulla Chandra Rai. But Indians have given them a title which is a much greater honor. So this section is about the two acharyas. So really Indian science took off. And there was a few oscillator examples before, but it took off with these people. So PC Rai, so I will go over this part a little fast because I'm running out of time. But anyway, these are also well known. So he was born at Joshua. He was deeply influenced by Sir Isaac Newton's lectures on chemistry. He went to Edinburgh and did his PhD. Then he returned to India, and it took him 6 years to get to research laboratory. Then the first study he made in India is a very Indian study. It's a study of adulteration in mustard oil and ghee. And he discovered that groundnut oil, teal oil, mahua, and fat have been put in these oils. Okay. Then, of course, the famous discovery of mercurous nitrate, the compound which should not exist, was discovered in 1895. A series of things that the famous French chemist Berthelot, he described Rai as the master of nitrites. He also did a study of history, a history of Hindu chemistry, founded the Bengal Chemical and Pharmaceutical Works. When the new postgraduate department of chemistry was founded in 1916, he became its first head. And as you perhaps know, that he was led a very ascetic life. He gave up his own house. He used to stay in the laboratory, and in a small room adjacent to the laboratory, and he lived and died there at the age of 83. So he even looks like an ascetic in these pictures. However, and of course, he is the first to have set the example, which today everyone is trying to do, of entrepreneurship to use science. And that, of course, is the famous Bengal Chemical Works. These products, many of them are familiar to people. Okay. And here in the city, and here is a picture of him with some of his students, out of whom, of course, S.N. Bose is here, Rishad Saha, J.C. Ghosh, Kiran Mukherjee, Amar Chakravarti. So that, and as you see, he was very thin because he used to eat properly. But he doesn't look too ascetic here. But later, of course, he looked like a sadhu. All right. Now, 4 of his students became big leaders in their own right. Who were they? Nilratan Dhar, who is sort of the father of Indian physical chemistry, and he spent his life in Allahabad University. Then J.C. Ghosh, he was the main subject was electrochemistry, and of course he also had many administrative positions, director of ISC, founder director of IIT Kharagpur. I'll come back to that, and vice chancellor of Calcutta University. Then we come to J.N. Mukherjee, father of Indian soil chemistry, and he was became director of Pusa Institute later. And of course, all of these are very big names in chemistry. Finally, Viresh Guha, who is the father of Indian biochemistry. So you see here that there are 4 fathers. Okay, and P.C. Roy was the grandfather of all of this. So Indian chemistry basically started with P.C. Roy and the people he trained. Maybe I should tell you a little anecdote. So apparently P.C. Roy he was a fellow of the Royal Society. He went to some meeting of the Royal Society, after which there was a dinner. And at the dinner, some lady asked him, so you're from India, how many children do you have? So he said 73. Okay. So the lady was totally shocked. So she assumed that since he has 73 children, he must have at least 20 wives. So she went and complained to the president of the Royal Society that what kind of man have you invited? The president laughed and told him he's a bachelor. And what he means by his children are his students. So, yes. All right. Now, of course, J.C. Bose, I want to give a whole talk and whole course on J.C. Bose. He was deeply influenced by Father Eugene Lafont and his lectures on physics at St. David's College. Then he did a BSc at Lord Rayleigh and a DSc from University of London. He returned to India, and of course, after that, he came back and started. He was sort of got a job almost immediately. He started working on the electromagnetic wave, which had just been discovered, say 1894, 1888. And of course, then in 1896, he perfected the radio receiver, which is called the Mercury Iron Coherent. And he demonstrated the Royal Society, but famously he refused to patent it. The result was that Marconi used the same thing to develop radio and won the Nobel Prize for it and patented it. And only in 2012, long after Bose had passed on, is he recognized as the father of radio science. So it is important. It's an important lesson that when you have made a discovery, please patent it. He also pioneered microwaves, all these horn antennas, dielectric lenses, polarizers. He was also the first to discover galena. Use galena as a semiconductor detector for radio. And for the same discovery, Brown won the Nobel Prize, which he shared with Marconi. So it's to add salt to the injury. Both these guys who had done things which J.C. Bose had done before them were given the Nobel Prize together. And Sir Neville Mott much later admitted that Bose was some 60 years ahead of his time. And he was a perfect example of what you heard in the morning, what Professor Chakravarti called Jugaad. So there's a famous example. He needed a dielectric, so condenser. So what he did for microwaves, so large wavelengths. So he took a Bradshaw, which was a big timetable, and put metal foil between the pages. And the paper acted as a dielectric, so he got this nice condenser. So, I mean, this kind of ideas, he used many of them. But of course, his more famous work is with this instrument, the crystallograph, which is now kept in Bose Institute. Probably not in very good condition, but it's there. And this measured motions of plants very accurately. With this, he was able to make many deductions about plants. So he used to discover that plants have a pulse and circulation, how they respond to stimuli, how they can communicate with each other. Then he went further, discovered the phenomenon of metal fatigue, and it led him to a kind of pantheism to say that everything in the world has its own ways, very similar to the way we react. So when he actually said these things, went to the West, and this is from an American, the Los Angeles Examiner, people were really excited. He made an enormous name. But there was also a reaction against it. The Orthodox Christian community were very much against it. They said he's trying to preach Hinduism through science. And the Royal Society stopped publishing his papers. And not only that, at the same time, one or two English scientists tried to steal his results. So Bose got fed up. He decided he wouldn't go back to England anymore. His further researches were all in his books, which he has published. So he was rather badly treated, given but I think he's the person who would have won at least 3 Nobel Prizes. Now here's a recent paper for news from 2024. Scientists film plants talking to each other. Now we have much more technology. So you have rediscovered what this man told you 100 years ago. And nowhere will you see here, anywhere you will find no reference to J.C. Bose. Okay, so as I said, no isms, I have just present facts as they are. And like J.C.'s friend, he inspired a whole generation of young scientists. Some of them you saw in the previous ones. D.N. Bose was his nephew, and B.M. Datta and Sinan and Arsen all became very famous scientists later. All right, Bose Institute. So Bose Institute, again, little story connected with it. There was a lady called Sarah Chapman Hall, an American who was a devotee of Swami Vivekananda, who wanted to donate some money for Swami Vivekananda to build an ashram. So he said, I don't need money. You give it to J.C. Bose. He needs money to build something. But at that time, J.C. Bose was under attack from the British people. The British professors were very jealous of him. So this lady donated 20,000, with which he acquired that land. Then he needed 20,000 more. So he wrote to her, and she again gave him another 20,000. So 40,000 rupees in those days was huge. And you can see the quality of the building which has been created here. And all this came from that 40,000 rupees. And Jesse Bose used to refer to her as Ma, Amar Ma. He was so grateful. Okay. So Raychaudhuri Mukherjee, no introduction needed. Now the Calcutta University College of Science was set up in 1914. These are the people who gave money for that. So Taraknath Palin gave 14 lakhs, Rashtrapati Ghosh gave 21 lakhs. Just to put it in perspective, I should say that at this time, same period, this is 1914. In 1920, Ramanujan is writing to Professor Hardy that I have a clerk's job and I am paid 20 rupees a month. Okay, now perhaps that was a low salary, but still, if you compare 20 rupees a month to these kind of sums, and of course, they didn't give them all their money. They only donated what they could. So you can imagine the kind of money which lawyers, at least then, used to make. Maybe it's still true, but nowadays it's not all disclosed. All right. Now we come to Sir M. Visvesvaraya, and he was a civil engineer and a statesman. The most famous thing we remember is that he designed the Krishna Sagar Dam on the Kaveri. And he also did several things, including the Hirakud Dam. And he advised in 1950, when he was 90 years old, he was the main advisor on how to build the upper bridge of the Ganga, which is notorious for the shifting sands. He retired in 1909. He was appointed chief justice of the government of Mysore state, which then became the king of Mysore. And he played Diwar, 1911, Bharat 1955. As you see, he lived to more than 100 years, 102. So it's a long list of things which he set up. And among them, the land for the IIC was donated to the Tatas by him for 1 rupee. Not personally, but on behalf of Mysore state. It came from the king of Mysore, but he is the person who did all the negotiations. And you see him in his old age. This is the Krishna Sagar Dam. And on this side of it is the famous Vrindavan Gardens. Also, all the fountains, all of it was designed by Visvesvaraya. And Vrindavan Gardens, of course, is famous because a lot of movies are shot there. You may have seen this. What is that? All right. Now, of course, we have to mention Srinivasa Ramanujan. Now, Ramanujan, what to say? Ramanujan is the greatest mathematical genius who ever lived. Nobody understood how he did what he did. Nobody understands still how he got his results. The results people are still proving. Many of them people have not been able to prove where he got it from. And in a short life of 36 years, how he managed it, only he knows. So, okay, I won't talk too much about him. But of course, there's a nice movie about him, The Man Who Knew Infinity. And this is supposed to be Professor Hardy. And okay. P.C. Mahalanobis. See, he originally trained as a theoretical physicist. And he used to teach GR as a PG classes. In England, he read this journal called Biometrica and was inspired by the importance of statistics. So he started applying statistics to metrology. In India, he came in just like Biometrica. He made a study of castes. And by studying caste, he discovered that this quantity, which is called the Mahalanobis distance, is essentially a mean square kind of measure. He discovered it while studying caste. Then, as you know, he started the Indian Statistical Institute, helped by various people. He founded the journal Sankhya, the lines of Biometrica, studied ISI. J.D.S. Halden was in ISI for some time and he remained director till the age of 79. Also, he was a member of the Planning Commission. He oversaw the industrialization in India, the second, which is still known abroad as the Mahalanobis plan. If you go to a foreign country and they will tell you, yes, in India you have the Mahalanobis plan. Okay. And of course, he also played a major role. The first computer, modern computer in India was brought by eyesight. It's still there. I mean, what remains of it. And the second was built in the IFA. And the first one was in eyesight. This is the eyesight building. And here's the picture of Mahalanobis, of course, and his wife. Third person, I don't know. Now, I don't know how many of you have heard of Ruchiram Sani. So Ruchiram Sani and his son, Birbal Sani. So he was a scientist, specialist, social reformer. He worked at Lahore and he was a man of many parts. So he trained in physics and meteorology. worked in radiochemistry, various things. He joined the Brahmo Samaj. He was a tireless crusader of superstition. For some time, he went to Cambridge and worked with Rutherford. That's also there. So, man of many, many parts. And Iqbal Sahani, of course, is the father of dendrology, which is the science study of fossil trees, fossil plants. So he trained in botany and various things. He's a pioneer of paleobotany in India. Also worked in archaeology and numismatics. And today there is a Birbal Sahani Institute. This is the Birbal Sahani Institute, and it's in Himachal somewhere. And here,
Birbal is in Lucknow.
It's in Lucknow.
It's in Lucknow.
Lucknow is the GST lab.
Okay, yeah. Right. It's a Lucknow. So this is that, and this is the main museum there, which has dinosaurs and things. Now let me talk about Janki Amman, who is sort of not so well known, but she's India's first woman PhD. Okay, from India, but of course not from India, but PhD is with his course from America, from Michigan. But she trained as a botanist, was something, and then she came back to India and worked at this first for some days at Trivandrum, and then she joined this sugarcane breeding institute at Coimbatore. And here she produced several hybrid sugarcane breeds with high yield. Now today, all the sugar you eat comes from that particular breed. So earlier sugarcane was always sweet, but not so sweet. So the sugarcane which is sold on the street side, these are grown. These are the sugarcane developed by Janki Amman. So next time you put sugar in your tea, remember that you owe it to Janki Amman. And then, despite this, as soon as she became famous, there's a lot of caste and gender discrimination, for which she left and went off to London. In London, she didn't work on this. She worked on poisons. Perhaps she had seen enough of toxic people. So she worked on this and worked on medicinal and poisonous plants, developed a more delicate version of magnolia. I had the pictures of this in this talk. Then in 1951, the Prime Minister invited her to come back to India to join the Botanical Survey of India in Kolkata, and she became director of the Central Botanical Laboratory at KalaBhavan. Now, what is interesting is that here she worked on brinjal. So the traditional brinjal, begun, is the long one. So you will see that still the practice is almost gone. But when we were young, then at weddings and such things, only the long bagan would be served. This round bagan, which is more juicy and more tasty, was developed by Janki at Allahabad. So next time you have your begun bhaja, you will go into the Janki. And the point is that, and the first place she wanted to cultivate in large things, the mud flats across in Banaras, across from the city at Ramnagar, that is where these were cultivated. So in Calcutta, you will still hear the word Ramnagar in begun. That is actually Janki Amman's begun. So later, she lived a long life. She worked briefly in BRC. Then she also spearheaded the movement to save the silent wilderness biodiversity. You see her young here and first old here. And recently, people have developed a rose, and it's named after her. Okay. Now, Calcutta University, the peak time was when all these people, famous names, I don't know, were all in Calcutta University together, and this was the youth. These are pictures of their youth. Of course, they all aged later. There are pictures of their age. And let me go over each of them just one by one. I'm absolutely out of time. So D.M. Bose, he worked in nuclear and cosmic physics. So for Mesotron, he was also the teacher of BHU. S.K. Mitra is famous for having discovered the D layer of the ionosphere, also found in Institute of Radiophysics and Electronics at CU. B.B. Roy, who worked in spectroscopy, he really discovered the Raman scattering of X-rays. And if you have done your physics laboratory, you know the resistance code is remembered by this mnemonic. B.B. Roy of Great Britain, very good wife. I don't know how many people remember that. Okay. So there must be some story behind it, but I don't know anybody who can tell me that story. Well, of course, the two famous ones. Saha, we know, discovered the Sahanization formula. Then became Khara professor, director of ICS, founded the Institute of Nuclear Physics, built India's first cyclotron. He also S.N. Bose, you just heard his own voice. Of course, you all know he discovered Bose-Einstein statistics. He was national professor. He's one person who didn't like administration. He was vice chancellor of Vishwabharat for only 2 years. Raman, India's one and only Nobel laureate. So some of the details. So one important thing is that even when he was a student, he published papers, and Lord Rayleigh used to write to Professor Raman, who was an undergraduate student. And then he joined the Indian Finance Service, which is now the Audit and Account Service. He was posted in Kolkata for a salary of 2,000 rupees per month. And then when he became Palit professor, he didn't have a PhD, so he was given 1,000 rupees per month. So he left a lucrative job to do science. Nowadays, people do the opposite. So, but that is one remarkable thing. Of course, you know about the Raman effect, Nobel Prize, director of ISC, founder of RRI, the first set of Bharat, is one of them. He was brilliant, outspoken, and also given to many controversies, which we'll have to learn, hear about on a different occasion. And of course, only Nobel Prize won by an Indian was Raman. Now, India became independent. All of this was done in the colonial period against all the odds which you face in a colonial country. Then after 15th August 1947, that is Clement Attlee, and India became free. Now with free India, I won't talk about individual scientists anymore, because there have been many, including the founder of this institute, who have made really important contributions. But I will just talk about the major institutions set up. Okay, very quickly. So Homi Bhabha set up atomic energy. He founded TFR, he founded DRC. He started the Atomic Energy Commission. Here is TFR, this is the DRC reactor. So this came, and of course, thanks to him, we owe, thanks to him. So at the time of Homi Setna, who was the director of DRC, Indira Gandhi was the prime minister. You know this story, the Buddha has smiled. So the first nuclear blast made by India for peaceful purposes. Then Vikram Sarabhai started space research. So he started as a cosmic ray physicist, but he founded PRL, started ISRO, was the chairman of Atomic Energy Commission, died at the age of 52 very suddenly. ISRO, this is PRL. And of course, thanks to Vikram Sarabhai, today we are able to launch the PSLV, and also we can dream of Mangalyaan 2, which is supposed to go and land on the surface of Mars. Third person, Shanti Swarup Bhatnagar. Okay, and these are all the CSR labs. He was a professor at BHU for some time, and I have to tell you about this because I'm now at BHU. And the BHU anthem, or the Kulgiti of BHU, was actually written by Bhatnagar. So he was a poet as well as a scientist. And of course, he started the 5 labs. He also died very suddenly in 1955. Then I think his mustache has become unfashionable nowadays. All right, and of course, here is the latest, the last one. And this is another award prize. And this is the first president of India gives out the prize. D.S. Kothari founded the DRDO, many things in addition, but most of the DRDO, he was also chairman of the UGC, to which made many contributions. And he worked at this Delhi University Department of Physics and Astronomy, and this UGC, and of course the DRDO is also founded by him. Yes. And then finally, of course, today, the fact that India is able to indigenously build an aircraft carrier is due to the efforts, the pioneering efforts of D.S. Kothari. Bharat M.S. Swaminathan, who died fairly recently, his daughter has just become an FRS. He founded, working on the Pusa Institute, he developed all these high-yielding varieties, which have led to the Green Revolution. Verghese Kurian, well known for Amul, for the milk. And it's interesting that he was trained as a nuclear physicist. He started working at BRC, and then his passion was for this. So he went off, and this is a range of, this is the Amul main factory, the range of Amul products. Probably there are some in your home also. And of course, the story of his early struggles is very well captured in the film called Manthan, starring Smita Patil and Girish Karnad. And so it's a very beautiful film. Maybe it's sort of a bit forgotten nowadays. Now, Amul is also famous today for something else, for its beautiful advertisements, which are cartoons and which have cartoons and puns and are always contemporary. Here is one, and even more relevant to us. All right, so Amul, it is also always interesting to watch their cartoons. A little bit about the IITs. So the first person to think that India should have a set of engineering schools of very high quality was Sir Ardashir Dalal, who was once manager of TISCO, but he was then a member of the Viceroy's Executive Council in 1945. This is Ardashir Dalal. But then Sir Nilini Sarkar was the chair of a committee which laid out the blueprint for a new set of institutes on the lines of MIT. And J.C. Ghosh, as I said, I'll come back to him. Dr. B.C. Roy provided the entire Hisley Jail campus. So Kharagpur students say that it hasn't changed. This is the picture of the original Hisley Jail campus. This is a typical watchtower which is there in jail so that you can see convicts are running away. And so J.C. Ghosh became the first director. And yes. Okay. And IIT Act was passed in 1956. All this IIT Act, which has the entire blueprint of IITs, was mostly created by J.C. Ghosh. So that is his biggest contribution, apart from the chemistry. This is IIT Kharagpur as it is today. Here are the other IITs which came up then. IIT Bombay, set up next one, set up with experts from the USSR, Russia. IIT Kanpur, set up by Americans. IIT Madras, set up by Germans. And again, IIT from various countries at Delhi. And of course, today we have many more IITs all across the country. So the ones in the green and red are the old ones. And then Guwahati and Roorkee came in the middle. And then all these red ones have come very recently. It's very recently, maybe 10, 15 years. People have mostly forgotten about Rajkumari Amrit Kaur. She came from the Kapurthala royal family. She was educated at Oxford. For a long time, she was Mahatma Gandhi's secretary. She was chair of the All India Women's Conference. She became the first health minister in the first cabinet of India. And she set up the first All India Institute of Medical Science in AIIMS. This is a picture of the first person taking the Covaxin. It was first given at AIIMS, Delhi. And she was the Time Woman of the Year in 1947. The AIIMS came up, AIIMS Delhi came up on the place donated by her own house, which she donated to AIIMS. And of course, this is not that house. This came up later because the house was very old and must have fallen down. Now, of course, there are lots of AIIMS in India today. Some of them have come up, some are being planned. Okay, most of them have come up now. And of course, this is a site which during the lockdown became very familiar. Every day. This is Dr. Gulati, who was then the director of AIIMS Delhi, and he would come regularly telling you to wash your hands, to wear masks and so on. Now, three things which have come up since, from which we have hopes. The nanotechnology mission came up in the about early 2000s, and various applications, and there are hopes. Feynman is this is Richard Feynman, originator of nanotechnology, and this is Professor C.N.R. Rao, who's sort of pushed it in India. So we have hopes from that. And there are many things which came in. I'm just focusing on things. Then, of course, the National Quantum Mission, which is based on quantum entanglement, started with Einstein, Podolsky, and Rosen. This is the present CEO. These are two of the young scientists who are doing great work in this. One is Vijayaraghavan from TIFR, one is Vibhor Singh from ISC. Both of them are doing great work actually building quantum computers. Last but not least is the National AI Mission, that is Alan Turing. These are the people who won the Nobel Prize for. And then you see the importance of. Can I go back? So you see the importance. IIT Kanpur alumnus gets a 800 crore package to do work with AI and ML. And it is important that India also be in this game. So this is sort of the latest effort. So it's time for me to end. Okay, well past my time to end. So you may remember that this slogan was coined by Lal Bahadur Shastri, Jai Jawan, Jai Kisan. And after the Pokhran 2 blast, the Prime Minister Atal Bihari Vajpayee added to that Jai Vigyan. So on that note of Jai Vigyan, I end my talk. Thank you.
So thank you, Professor Raychaudhuri, for a beautiful, informative, and insightful talk. So there will be many questions or comments, but we can take a few of them if you have.
Yeah, wonderful talk. I mean, I could also learn many things. Just one thing that JC Bose's that Galena crystal detector, that one he patented. But why did he get the Nobel Prize? For electromagnetic waves, of course, the patent was not there.
You're right.
But the Galena detector, the patent was there. And this light, I don't know. If you check, Galena should be red sulfide, not the zinc sulfide.
No, I thought.
Should
I checked.
Should this?
I checked.
Maybe also wrong.
I thought it was supplementary. I checked.
Yeah. So, but he patented that one. That was the 1901 patent.
He patented in America.
Patent in America. Yes, patent. Yeah.
But yeah, so why the Nobel Prize is given and why it's not given is something which is not revealed. But yes.
This is the first semiconductor
Of
detector.
course, you should have got it. I mean, there are three things for which you could have got it, easily got it.
So just check that. I may be wrong.
So I don't know why he got it, and that information will not be anywhere. Why did he? It? But whether it's zinc sulfide or whether it's sulfide,
Just check.
Yeah.
yes.
I have the mic. So fantastic. It's a fantastic overview. So I have actually a related question. So of course, it looks like that Marconi's design was quite different from that of JC
Not at
Bose.
all.
And
Not at all.
that is what is being claimed, that the
Absolute
design
nonsense.
is different.
Absolute nonsense. JC Bose had a YouTube. Marconi made a straight. That was the difference.
I see.
The principle, everything was the same.
Is it also true that JC Bose actually demonstrated the experiment
Yes.
at the Royal Institute
He went
and
demonstrated-
Marconi was in the
No,
audience?
Marconi was not in the audience. He demonstrated at the Royal Society. After that, JC Bose's own letter exists that he says one English businessman who was attending it came and told him that you should not reveal everything. Let us patent it. There's a lot of money to be made out of it. And according to JC Bose, his eyes were shining with greed. Okay. And he's writing this letter to Tagore. So the letter exists. But he refused to patent it. He's saying that discoveries are for the world. Very high-minded. But he had not reckoned with Marconi. So of course that thing was reported. It's in the Royal Society proceedings.
Yeah.
Marconi read that, like everyone else. And the thing which Marconi did see, previously people could design transmitters, but nobody had designed a receiver which was sustainable. And for example, the receiver design, there was one designed by this guy, I've got his name. So the British scientists had designed a receiver, but that receiver, every time after getting a signal, you had to tap it by hand. So for JC Bose, it was self-recovery. So you could go on and on. It didn't need mechanical. So that's why it was sort of the only working thing. And he didn't patent it. As I said, the difference between this, so he used mercury and iron, and the Marconi's thing also is mercury and iron. Same principle touching the meniscus, except that JC Bose had made it a U-tube, and Marconi made it in a straight tube like this. So that's all.
Thanks for this clarification because it's safe when it
It's in my book.
lessons.
It's in my book with the diagram.
IEEE has recognized this fact that JC Bose discovered the microwaves. This is on record now.
Yeah.
I should know it.
I should.
No, microwaves, all the original research was done by JC Bose. And in the process, how to focus microwaves and so on, all those things were developed by him. Later people have used them for lasers and so on. Same thing. And it is in that context that Neville Mott said he was 60 years ahead of his time.
Any further questions?
People are talking of ionic liquids now, but PC Ray was the first one to do that. And he had published also.
Ionic liquids?
Yes.
Okay, I didn't know that. I thought ionic liquids were all studied by Faraday.
No, this, there is a reference about it, that he has published it to us.
Okay, good. I'll look it up, but I didn't know one.
Okay, so if there is no further question, let's stop the session, close the session now. And thanks to the speaker once again. Any announcement?
So we will end the session now. There's some tea outside. And there is a cultural program scheduled at EZCC at 5:30.